This is a short video in which I'll take you through working with vector types in Helios. These vector types are fundamental to almost anything that you'll do in Helios. Almost any call to the API is going to take Helios vector types as arguments. So what exactly are these vector types and when might we go about using them? So in many different instances, there are cases in which we need to represent or store multiple values together. And so this is because they're related. So we could store them as separate values, but it's often convenient to have them grouped together. Let's say if we want to do some operation on them all at once, or we want to compute something from them, or if we want to pass them as an argument to a function, it's nice to have those sort of grouped together. And so one common example is representing a 3D Cartesian point in space. So let's say that we had some coordinate in space that we wanted to represent, which has three components. It has an x, y, and a z coordinate. And these are always going to be related to each other. If we have a point in 3D space, we're always going to have three values. The first value is always x, second value is always y, and the third value is always z. So in Helios, we have special data types that group together these related values. For our example of representing a 3D point in space, there's a struct called a vec3, and this has three data members. It has a floating point value called x, a floating point value called y, and a floating point value called z. So this is nothing but a struct in C++, and it has special meaning because it's a three-component vector, usually used to either represent a unit vector or a 3D coordinate in space. It's also important to point out that all of these Helios vector types are within the Helios namespace. So this is not a type within C++ itself. This is a special data type that is part of Helios, and so it's stored within the Helios namespace. So first things first, let's continue with our vec3 example and talk about how values are initialized. So we saw that we had three data members, but we usually would want to initialize their values and also read those values later. So one way is by using the default constructor. So if we just declare a vec3 and we don't give it any arguments to initialize, it's going to by default initialize all of the values to 0. And again, just another reminder that if we're using namespace Helios, then we could omit the Helios : in front of the vec3 type. We can also explicitly initialize the values within our vec3 if we wanted to. So we could declare our type. So you want to think about the vec3 as just another data type like an int or a float. Then we have the name of our variable. And then if we pass it an argument by using parentheses after the name of our variable, then we can specify the values of x, y, and z in that order based on the argument. So there must be three values. It's always going to assume that the first argument that you passed corresponds to x, second argument is y, third argument is z. So here we would accomplish the exact same thing as when we just used the default constructor with no arguments. Here we're just initializing to 0, but you can change these values to initialize it to something else. You can also pass a variable in to initialize it based on some variable value. And lastly, there's this function called make_vec3. And in this case, we can use it to do an assignment. So the make vec3 is just going to basically create us a vec3, which we can then use to assign. So we could declare a vec3 called position and then use the equal sign and then use make vec3 to assign it. We can also use this make underscore function if we wanted to say, skip the declaration and just pass a vec3 straight to a function, for example. This is just going to be kind of an in-place way of defining all the values within our vec3. And this is all specific to just a vec3 as the example, but there are many different types and they all follow kind of the same rules. This is a table showing all of the available Helios vector types, which you can find in the documentation by going to user guide and then using the Helios API. So we have a 2D, 3D, and 4D vector of floats. This is vec2, vec3, vec4. And if we just have a 2D vector, we have only fields xy. 3D, we have xyz as we saw. 4D, xyzw. We also can have a 2D, 3D, and 4D vector of integers. So that's int2, int3, int4. Same data fields as with a vec3 or with a vec2, vec3, vec4, except that they have type of int. We also have some others called a spherical coord or a spherical coordinate. I'll talk about that in a future slide in just a second here. This has data members of radius, elevation, zenith, and azimuth for representing spherical coordinates. We can also have colors, so an RGB 3-component color with data fields of R, G, and B for red, green, and blue. We can also have an RGBA color, where here the A is the alpha or transparency value. We also have a time vector, that's the time of day, so it has hour, minute, and second. And then we have a date vector that has the year, month, and day. Some of these have member functions that allow you to perform operations on them. For example, a vec2, vec3 has a normalize and magnitude function that you can use to normalize its magnitude to 1 or to get the magnitude of the vector. The RGB and RGBA colors have a scale function where you can scale the color. And then we have some functions associated with the date vector where we can convert it to a Julian day or increment the day or query if it's a leap year. These vector types also have a number of overloaded math operators. So if we're working with a vector of floats, we can do the dot product by using the asterisk. So this will compute the dot product between two, say, vec3s. We can just multiply by a scalar as well, also using the asterisk as we normally would. That is going to multiply each element in the vector by a scalar. Same thing with the divide sign. We can add two of them together. We can subtract them. We can increment all of their values. We can test whether two of them are equal to each other with the double equals, similar as not equal. And then this double angle bracket is for printing them out to the command line. And then we have our creation function, that make underscore, as we talked about previously. So a quick note about spherical coordinates. These are very important within Helios. They're often used to do rotations. So in a spherical coordinate system, we have three unique components. We have the radius of the point, so this tells how far it is from the origin. We have the azimuth, which is essentially the compass direction. So if you rotate about the vertical direction, this gives the angle from the y-axis. And then we have the zenith or elevation angles, and these are just the complement of each other. So the zenith angle is the angle of the vector or the point with respect to vertical or the zenith. And then the elevation is just a complementary of that. It's the angle between the vector and the horizontal direction. So these two are linked to each other, the zenith and the elevation. If you know one, then you already know the other. For this reason, zenith and elevation are read-only because their values are linked. If you were to just set one of them manually, then the other one would become out of sync. And so if you want to set their values, you have to use the make underscore function and then assign it to that spherical coordinate. And we have some built-in functions to convert between spherical and Cartesian coordinates. These are sphere to cart and cart to sphere. You can use to easily convert between a vec3 and a spherical chord. And lastly, we have a number of built-in RGB colors. So we have 20 predefined RGB color values. So these are referenced using the RGB in capitals and then 2 colons, and then the name of the color. And this table here, which is also in the documentation, shows what those are. You can also make any custom RGBA color or RGB color just by using the make_RGB color function or by using its constructor to initialize its values to anything that you want. The important thing to note about the convention used in Helios is that components are normalized between 0 and 1 instead of being between 0 and 255. All right, now let's run through some quick examples by writing some code in CLion. So I've gone ahead and already created a new project. I called it vector_types. Let me show you what my CMake list file looks like. We don't need any plugins. I've just called our executable vector_types. And then I've opened up a blank main.cpp file. We're just going to include context.h. And then our main function is going to return 0 so that it doesn't complain that our function doesn't return a value. And again, we're not yet in the Helios namespace. So if I want to, for example, declare a vec3, then I need to type Helios : and then vec3. So this is my data type. You can think of this like int or float or string or whatever. It's a type of vec3. And then next comes the name of the variable that I want to call it. So let's call it some vector. And I could end right there. And as we discussed before, this is going to initialize the x, y, and z components of some vector to all be 0 because we're using the default constructor. I could write out this vector to the command line. So if I did std cout, and then I could write some vector. And then if we go ahead and run this, it's going to print out the value of our vec3 to the command line. And as we said, it was just initialized with 0, 0, 0. So I could initialize it to some other values, let's say 1, 2, and 3, for example. And then if I run that, it should print out that our values are 1, 2, and 3. And I could also use variables. Let's say I want to say float x equals 1, float y equals 2, float z equals 3. Then I could instead pass variables here, y, z, and we should end up with these same results. Okay, we could now change the value of this vec3. We could say some vector equals and then make_vec3, and it's going to complain because we need to type Helios here. So make vec3, let's say 3, 2, 1 instead. And then we go ahead and run this. Now our value is 3, 2, 1. So we just assigned some value to that. So if we didn't want to type that Helios : over again, we could use using namespace Helios up here, in which case we could get rid of this and we could get rid of this. And if we did using namespace st and d, then we could get rid of these as well. I think it's sometimes nice to not use the namespaces and explicitly state what namespace each of these variables come from. That's so you don't get confused, especially if you're new to Helios. It can be confusing whether the variable type is from Helios or if it's something that's native to C++. If you're new to both, then it can be a little bit confusing. So this is one way to help keep it separate. Let's demonstrate some operators. So let's define another vec3 and call this some other vector. So these have two different values. And then we could compute the dot product between these two. So the result of a dot product is a float. So we'll call it dot result. And then we could take some vector times some other vector. And because we're using the asterisk operator with between two vec3s, then it's going to know that you want to compute the dot product between those two, and the result is going to be a scalar. So we can instead write out our dot result. We can go ahead and run that. And the dot product between those two is 10. So that'd be 3 times 1 plus 2 times 2 plus 3 times 1 should give us 10. Okay, and let's say that we wanted to convert some other vector into a spherical coordinate. So we could do spherical coord, let's say converted vector, and we could assign that as cart to sphere of, let's do some vector. And then we could write out converted vector and see what its value is. And there it is. The first value is our radius. The second value should be our elevation. And then the third value is our azimuth angle. I could also access each of these values separately if I wanted to. So I could do dot radius and then write out, let's say, converted vector. I want to write out the zenith instead of the elevation. And then I want to do azimuth. I could write each of these out. And there would be our radius, zenith, and azimuth. I could also change just a single value within this vector if I didn't want to reassign the whole thing. Let's say I did some vector dot y, and then I want to assign it a value of 4, for example. Then it would change just the y value, and it would continue running on everything else. Could run that again, and our values should change because the y value is now 4 instead of 2. And one last thing to illustrate here is, let's say that we tried to modify the zenith or elevation angle of this spherical coordinate. So maybe we tried to do converted vector dot zenith equals 3 or something like that. It should give me an error, and it will say that you can't change the value of a constant or read-only value. And that's it for this video. Hopefully that helped a little bit with getting going with Helios vector types such that you can move forward with some of the other aspects of Helios.